This is Lab 3, Part 1, 2D viscous flow over an airfoil at frequency of 60 hertz. So we are going to start by going to SolidWorks and sketching the wind tunnel geometry, and then also sketching the shape of the airfoil in there. Input all the dimensions, exit sketch, and then you're going to insert surface planar. That'll give you this. And then you want to save that. Go over to the ANSYS workbench, start a new fluid flow simulation. I'm going to change it to 2D and import our geometry. Just make sure it imports properly. I hit generate and make sure the shape is there. And then you can close out of this. Then we're going to update the mesh real quick. And then we are going to go edit the mesh. First thing you want to do is hit mesh, hit insert. You want to choose this face, hit apply, and then change the method to triangular. Normally, for element size, you would want something very small, like 0.005, but for the video, to speed things up, we're going to do default sizing. Then you're also going to right-click, insert, sizing, and come and select hit selector up here. And then hit apply for geometry. That doesn't look right. I'm gonna try that again. Okay, I'm just gonna assume that's because the number of Divisions is too small? Yeah, okay. So select those edges and hit applied, then change this to number of divisions and hit in number like 100 or 200 or something like that. Okay, and we're gonna generate the mesh. Okay, now that looks good. Last thing we're gonna do before we exit the mesher is name the edges. So edge selector, click on this one, name it velocity inlet, name the outlet pressure outlet, and then name the rest of the walls, and you can name the airfoil airfoil. Okay, everything looks good. We can exit out of that now. We're going to update the mesh again. Okay, now we're going to edit setup. 2D, double precision, display mesh after reading, and then hit start. Once everything loads in here, make sure the model is set to viscous, energy off, make sure the fluid is set to air. For boundary conditions, velocity inlet, we are going to change that. For 60 hertz, it should be around 4. Apply, close, reference values, compute from the inlet velocity, and we're going to make a drag report. Now click on initialization and hit initialize. Once that's done, it is time to run the calculation. Just select for number of iterations, something high like 100 or 200. We're going to do 150. Make sure everything else is good before I do this. All right. Okay, once that's done, we can take the drag force, take this number and use that to find our drag coefficient. You can also just check on the contours and make sure everything ran correctly. Okay, once that's done, we have all the drag data from there. We can close this out. And then when we can go to results, hit edit. And we are going to sort of velocity vector, symmetry 2, vertex. This is all good. This looks a lot better when you have more. Your meshing is finer, but this will do. This will do just fine for right now. Kind of see that it looks like it should. Okay. Then you can just save picture from there and save it to your computer. But then you can also insert. You want to do a pressure contour as well. Location symmetry. Well, either one's fine. And then the last one we're going to do is a streamline. 2D or surface symmetry 2. We're just going to do something like 50. Okay. Well, normally that works. Okay, there it is better. But if you do more streamlines, say like 50, a little bit more defined shape there. You can do 100 if you really wanted to. Um, that is it for the ANSYS simulation for Lab 3, Part 1.